For years, we've kind of thought of AI as this black box, right? It just spits out answers with this unshakable, almost scary confidence. But what if an AI's most powerful, life-saving feature wasn't its confidence at all, but its ability to just stop and say, I don't know. Today, we're going to look at this massive shift in medical AI where uncertainty isn't a bug. It's actually the key to saving people's lives. For the longest time, the whole idea was that an AI model should always give you a definitive answer. It didn't matter how weird or incomplete the data was. And this, as you can imagine, created a huge, huge problem, especially in a field like medicine, where trusting a confidently wrong answer, well, it can be absolutely disastrous.
And look, this is not just some theory. This is real. Back in 2021, an AI pathology tool did exactly this. It looked at tissue samples and, with zero hesitation, told doctors that perfectly harmless growths were cancerous. It wasn't just a simple mistake, it was a catastrophic failure that showed everyone just how dangerous an AI can be when it doesn't know what it doesn't know.
But that entire way of thinking is now being completely flipped on its head. There's a whole new generation of AI coming out, and it's built around one simple but honestly profound idea: the ability to measure and communicate its own uncertainty. Let's just call it the I don't know AI.
And when you put them side by side, the difference is just night and day. The old AI, a total black box. It gave you one answer, usually way too confident, and was prone to these silent, devastating errors. This new AI is totally different. It gives you a diagnosis plus a confidence level. It tells you straight up when a result is shaky. And this is the most important part: it knows when to just stop and ask a human for help.
So what do we really mean when we say uncertainty? Well, think of it as the AI's own calculated self-awareness. It is not a flaw. It's not a weakness. It's a feature built right in that basically measures how much the AI trusts its own answer based on the data it's looking at. It's like a built-in gut check. Okay, so this is where it gets really cool. How in the world do you actually teach a machine to doubt itself? Well, it all comes down to a few key pieces of technology that give the AI a healthy dose of skepticism. So one of the main ways is to just build doubt right into the AI's brain, so to speak. Instead of one single model, you can use things like Bayesian neural networks, where answers are always seen as probabilities. Or, my favorite approach, you use something called ensemble methods. It's basically like creating a committee of, say, 5 or 10 different AIs and showing them all the same case. If they all agree, the system's pretty confident. But if they start disagreeing with each other, well, the system knows something's up and flags its uncertainty. The other secret ingredient is giving the AI the full picture, just like a human doctor would want. It's like having a team of AI specialists working together. First, a CNN, which is a whiz at analyzing images, looks at the blood smear. Then, an NLP model, which is an expert in understanding language, reads the doctor's notes on the patient. And finally, a graph neural network fuses all that different information together, combining every single clue into one much more reliable diagnosis. And the payoff for doing this? It is massive. Just by combining these different streams of data, the images, the texts, the lab numbers, the system slashes its own diagnostic uncertainty by 30 to 50%. It's building a much richer, smarter understanding of the situation before it even tries to make a call. And this all leads to the really crucial part: how all this tech makes the whole process safer. See, the entire point of an AI that knows its own limits is that it also knows when it's time to pass the baton to a human expert. This is the human-AI handoff, and it is the heart of the whole safety system. So let's picture it. The AI has analyzed all the data, it's consulted its internal committee, and its uncertainty level is way too high. What happens then? Does it just take a guess and add a little warning label? Nope. It does something much, much smarter. It triggers something called a deferral mechanism. The second the AI's uncertainty crosses a preset safety line, it just halts the diagnosis. It stops itself cold to prevent an error. The case is then immediately flagged and kicked over to a human pathologist. And here's the cool part. It comes with notes explaining why the AI was confused. Maybe the cells looked weird, or the image quality was just too low. And you want to see the proof? The results of this are just undeniable. In clinical trials, just putting this deferral system in place, this automated handoff to a person, slashed the total number of diagnostic errors by an incredible 35%. It is literally a safety net that catches mistakes before they ever reach the patient. So, let's bring this all home.
Because this isn't just about cool tech or fascinating algorithms. This is about saving lives by completely changing how we use AI in the real world, in medicine. By knowing when to be unsure, these new AI systems cut down on the misidentification of benign tumors, the false alarms, by 40 to 60%. Just think about that. That's a massive number of people who are spared the fear and the stress and the harm of treatments they never needed in the first place. And it is not just about preventing those false alarms. The flip side is just as important. The very same system reduces the number of missed cases of actual leukemia by that same 40 to 60%. That means people get diagnosed earlier, they get treatment sooner, and they have a much, much better chance at a good outcome. So the future we're heading towards isn't about AI replacing doctors. It's about creating this, a calibrated partnership. It's about taking the incredible precision of a machine and combining it with the wisdom and judgment that, honestly, only a human expert can bring. And together, they are so much safer and more powerful than either one could ever be alone.
It really does leave you with one last thing to think about, doesn't it? We're out here building these amazing machines, and it turns out their greatest strength isn't just raw intelligence. It's the self-awareness to know when they're in over their heads. So if that's the pinnacle of artificial intelligence, what does that teach us about the importance of knowing our own limits?